Okay, sorry. Okay, so so what kind of other settings? So when the IK is selected, we can see this object actually it's based on world values. Okay, so something with IK we really need to pay attention. Huh? I tell you, we always work on the stance pose. Okay, and you need to pay attention to keep those values because if you kind of like hit them or move your rig, it will break everything. Okay, so pay attention to that. So when you are testing it, you can translate it and say, okay, it's working. But remember to undo and be sure that it return to your stance pose. Okay, so they have this here called twist. Okay, and actually right now it doesn't do much. Okay, because what? Because when I create this IK, if I go to the attribute editor and I scroll down, you will realize this IK is actually a single chain. So remember, a single chain, right? Control only the beginning and the ending. So the twist attribute actually will control this one here. But my IK is wrong. So I can change it to rotation plane. And you can see when I do to a rotation plane, there's a kind of an arrow on top. So this arrow actually will show the direction of the third position, the middle one. Okay, so that's a rotation plane. Okay, so it's okay. Like remember that. So when you create the IK, if by any chance you create the wrong one, so what you can do, you simply select the IK, press Ctrl A. You go to IK solver attribute, and you can change the IK type. Yeah. So everything you can change later anyway, right? So yeah, that's okay. Right. So here's the twist attribute to control the middle. There is something called pole vector. I will show you that in next classes. But actually, just for your information for now, pole vector and twist more or less will do the same thing. They are controlling the middle part, the knee part. Okay? So yeah, they do the same. Okay? So yeah. Okay, another setting here that we want to know, it's very important to know that setting, is here. It's called the IK blend. Okay, so you can see when IK blend is on, the IK is on. But if this is turned off, then now you can see my IK, it's not active anymore. Okay, so the IK blend setting here, it is the switch. Okay, to turn on and turn off the IK effect. Okay, so when the IK effect is disabled, what happened? I have to keyframe the joint. Okay, so let's say set a keyframe, maybe go like that, set a keyframe, this, set a keyframe. All right, so this is FK. Then what I want to do, maybe from frame 23, I will repeat. Okay? Yeah, it's the same. So from frame 23 to later, I will activate my IK, key selected, and now what? I can animate the IK. Okay, so this is the FK portion, and this is the IK portion. Okay, so this will work with the blend. Okay, but no worry, later on we will do the things in a way more simpler than that. Okay, so what you want me to repeat? What you don't get? Okay, so okay, so how to create an IK? If you're not sure, maybe you can hide the geometry first so you can see things clearly, right? Okay, so where we get the IK is inside the rigging module, inside scale 10, create IK endo. Okay, so when we have that, okay, so the setting we want to change right now, we want to change the current solver to rotation plane solver. And we simply want to enable sticky. Okay, do you need time to catch up on that? Okay, then you just click where you want to create the IK. So in the case of a leg, we want to control the leg in IK. So we will create the first, select the first joint and the ankle. Okay, then that's it. Now you have your IK created. If you look in the outliner, you will see there's a new object called IK endo 1. Okay, and when you translate this IK endo 1, it will move your system. If you move the twist, it will move the middle part. Okay, or the opposite as well. If I select, for example, the hips, you will realize then the ankle is staying in place. Okay, need me to repeat that again?
Yes or no? Yes. Yes. You guys are amazing.
Okay, I'm a bit.
Okay, I tell you what, you just draw a new two bone skeleton.
Huh?
Because some of them are still clicking on the hip, on top. You're still clicking on this.
And what? Okay, don't click on it long. Okay, guys, let's start again. Okay, reopen the file. Okay, reopen the file fresh. Okay, I mean it should not be very complex. Okay, and hide the geometry. Okay, now I want you to realize. Actually, before I hide the geometry, right? I want you to realize a couple of things. Look at this. This guy here, you see, this guy is the leg, is the beginning of the leg. And this guy is the knee. This guy here is the ankle, right? So don't click on this one. This guy here is more or less the representation of the hips. Okay, so that's not the correct joint. Okay, so we hide the geometry and we go to skeleton, create IK handle. Okay, by default, it will be a single chain. You want to change it to rotation plane, sticky. Okay, and now you just go and eyeball the first joint of the leg. Click. Now, as you can see, the full hierarchy gets selected. Then I will go and click until where I want it to end. It's at the ankle position. Done. Okay. So now we can translate this guy. We wish. Okay. Simple like that. Okay, raise your hand, people who need more time with this. Okay. So remember, when we talk about the IK, there is a warning. Remember, it's based on world position. Okay, so it's very easy to lose this by hitting like that. Then what happens is we destroy all our rig position. Okay, so it's not good. Okay, so a trick maybe if this happened to you and you move the IK and you lose your rigging position, what you have to do is this: you delete the IK, and actually you want to reset the joint rotation to 0. Okay, or a trick is to right click on the joint and say assume preferred angle. Okay, so the joint will return to 0. Okay, so it's okay. This we will practice this again shortly. Okay, so here a couple of indication. Okay, so this is what I will call for you guys the best rigging situation. Okay, so where actually the leg it's modeled in a total straight. Okay, and the arm is as well totally straight. Actually, if you do mocap, remember when you rig for mocap, you will need to rig the arm straight like that. Okay. What kind of situation when we rig is important for the arm is to have a slight bend on the top view. Okay, it's very important. We cannot have the joint to be super straight. It will create some kind of mistake. Okay. And if I look at the side view, okay, this is okay, but too straight. Okay, so generally as well, when we create the leg, we try to have a slight bend in between. Okay, So that's important. So please pay attention if you ever have to rig something. That is what you have to do. That's what I described here as well. Okay. Um, okay, so that one should be quite simple. Okay, so what I want to show you here is, I think you have seen with a two-leg character, we need to know how to create controller. Okay, so it's generally simple. Okay. Okay, so actually I propose to you to create the circle. There's three methods that you can practice later. The first one is very, very simple. Okay, so what we do, we can create a nerd circle. Listen carefully. Okay, so if I right click, go to control vertex, I can select the vertex of a circle and maybe twist them to have different looking icon. Okay, so this is a NURB circle. Okay, I will just show you here. Pay attention, because some people right away will go to create NURB square. Okay, a square is very different. A square is a group made out of 4 lines. Okay, so a square is not good. Okay, but if you want a square icon, what can you do? You can create NURB circle, and if you change the setting here to linear and 4, so this is look like a square. Okay, actually if you can use the history, you can still change it if you want to. All right, so that can be a way to create icon. Okay, so that's the first method. I want you to practice later. Okay, actually it's the first and the second, right? The third one, okay, now I'll show you the third one. The third one is slightly more difficult, but it's kind of fun. If you come here to create, where do you put it? Okay, create curve tool, EP curve tool, or this one, EP curve tool. Okay, so if I start to draw, you remember that will just create a curve. I'm sure you know this before, right? Okay, so let's review actually what kind of setting I changed. If I change it to linear, you can see it will create kind of a linear feeling, right? So why not actually use this, the linear method? Maybe I go to the top view to make it easy for me right now. Okay, and what can I do? I can use the snapping here to grid. So now look at this. Click, 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 click. 1, 2, 3, 1, 2, 3. Yeah. Okay, like that. 1, 2, 3. 2, 2, 1, 3, 3, 1, 2, 1, 2. Enter. Okay, so this is how you can start to create customized icon. Okay, I will repeat. Okay, no worry. Okay, another one. Okay, look at this one. It's slightly more complex. Okay, I want to create a cube. How to create a cube? Well, I will go to the top view first and hold down. I'm snapping to the grid again. So click 1, 2, 3, 4. So I have a square. If I look in my perspective, my square is there. So what I will do now, I will go to the side view or the front view. Then I will go 2 units before, higher, and snap again on grid. And you see when I do that, what happens is like that. So what I will do, I will continue now to snap to the top view. I will continue to snap to the grid. So click, 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 click. And now I will do some fantasy. So I'm using now snapping to vertex. Okay, so V, snapping to vertex because there's already have vertex existing here. So V, 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 and click. All right, press enter to terminate. Okay, so I will let you start to play with this. I will repeat that. Okay, I will try to have the circle first, modify the circle, then try to create this one. Okay, so for some of you, we'll start to repeat again. Create NURBS, and we don't want to create a square. Okay, we want to create a circle. Okay, and from the circle, actually, what is cool is you just decide how many section the circle have. Maybe you want to have 8 section. Okay, do you want it linear or cubic? Cubic is very smoothish, and linear is more linear. And from there, you can just pick a random set of vertex and change it to have any desirable shape. You can, it's almost infinite the number of possibility you can do. Okay, it just depends on is it cubic or linear, how many points you have. Okay. Wow, you're quite good already. Yeah? I see all of you can make use of animation to learn before. So are we good with that? No? Okay, I will repeat. Do you want me to repeat something? Okay, so it's very simple. Just decide what you want to do. I mean, if you don't know what to do, then yeah. So I always start with the NURBS primitive circle. Choose the number of vertices. Say we'll go to 16. Actually, yeah, 16. Right click on vertex, and I will try to design a special pattern where every 2 like that, I will pick. Then here, here, and here. Then I can scale like that. You can see everything will have different pattern. Okay, it depends on what you want to do. There's nothing really complex about that, guys. Okay, even at some point, can you realize that actually most of the controller are just a circle as well? So no big deal. The 3D one is kind of useful to be able to make the 3D one. I will repeat for those of you who are not sure. So how to make a 3D icon? We create a curve tool, and it's an EP curve tool. And my setting of the EP curve tool will be set to linear. And what I want to do is I want to go to the top view, and I will shape the icon like what I want. So let's say 1, 2, 1, 2, 1, 2. I will create maybe kind of a lozenge like that. Right? So now what do I have? Oh, sorry, I press enter. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So now if I look at my perspective, I have kind of a lozenges. Then I will go, you can see my vertex is here in the side view. So what I will do, I will go a couple of units higher than that. 1, 2, 3, 4 units higher. And I will repeat the same pattern from the top view. Hold down the V key to snap to grid. So now I get this. Then actually I can keep the icon like that if I want to. Or I can continue now to snap to vertex. So the snap to vertex is the V hotkey or this icon here. Okay, to V, and just complete what you intended. Okay, and after that, there's nothing else blocking you of designing it differently by just manipulating your vertex accordingly. If you want your icon to look like that, you can do it now. Right? You just move your vertex. actually, guys, before I forget, okay, the goal I want you to do, guys, is to create 3 icons, 3 different icons, no matter what they are, and I want you to save your scene. Okay, later on we will reuse those icons, so we don't need to recreate them all the time. Okay, so create 3 icons and save them. I will do so as well. Okay, guys, can I show you another way to do controller? One last way, okay? So just stop what you're doing. I will let you some time later to complete your 3 icons. Oops, sorry. Okay, so okay, okay. So the last way actually required you to do a little bit of scripting. Do you know about script? Really? So I suppose you all like it. Good. Okay, it's okay. You're not obliged to do it, but we'll still show it to you. Okay, you're not obliged to do it. Okay, so what to do? What I want to do now is I want to create a sphere. I want to create a sphere, an icon make like it look like a sphere. So what can I do? I will create 2 circles. I will come here, change the setting maybe to 8. Oh, sorry, to 8 and cubic. And I will duplicate this guy and I will rotate it 90 degree. Oh, 90 degree, like that. So this is the icon I want. Okay, actually maybe let's duplicate another time, Control D, and that's the icon I want to have. It will look like that, like a ball, right? Like a Pokemon ball. So you remember actually an object in 3D is made of a transformation node and a shape node, right? So actually, how can we see that in Maya? We can come to the outliner, display, shape. So now you can see they have a plus sign over it. And if I click here, this is the transformation node. This is the shape node. Okay. So actually, if I show you the comment we want to do is this. We want to parent minus S minus R. So minus the shape, the relative object. So we will give the name of the shape and the name of the object where we want to parent. Okay. So let's do that. So if I come to Maya here, in the mail section here, I can write down parent minus S space minus R. Okay, and the name of the shape here, let's pick the shape number 3. I will copy the name and put it here. Oops, sorry. And I want to parent it to nerve circle 1. Okay, so now you can see nerve circle 1 have only one shape. Okay, so if I press enter now, what did we see? The nerve circle 1 actually have 2 shapes. Okay, let me undo that because actually I should have freeze before. Okay, so I'll just pick those 3 guys, modify, freeze transform, and I'll just delete the history. Okay, so I can use the up arrow here to bring back the string. Okay, press enter, and now you can see the shape were in nerve circle 3 have been parented here, right? So I don't need the transformation node here anymore. I can delete it. Then I can repeat the same concept. I will bring back my comment. And here I want to parent the shape number 2 to the nerve circle 1 again. Press enter. And I don't need this. So this is become my icon. Okay, like I say, you're not obliged to do that. You seem to don't like scripting or something. I'm not sure. I'm not sure if I read this correctly. What you like or you don't like? What do you don't like? Okay, guys. So please don't take like 15 minutes to create 3 icons. It's a bit not what I want actually. We have real things to do soon. This is somehow just an exploration. I mean, it's a very simple thing. Okay, so remember when you have 3 icons to save your scene. Okay, guys, you see, to really overdo like your icon. Okay, if it's simple. Also, guys, something I didn't mention, but I strongly advise you to create those icons in the center of the world. Okay, so they are pivot. It's inside the shape itself. It's okay. We can change that later anyway. But it would be better if they are in the center of the world. Okay, raise your hand, people. Need 2 more minutes. No one? Okay, fine. Okay, so our next, actually our first practice, okay, to start to put everything together, the IK, the joint, and the controller, and a bit of constraint actually. So we will rig that crane. So you remember we used that crane, I think, for the constraint practice, but now we will learn how to rig a technical object. Okay, so you can all open the file called crane start. Okay, save your icon and open that file called crane start. Oh, hey, sorry, wait, don't open yet because actually someone overwrite the crane start file. I need to delete stuff and pass it to you. Yeah, but then close it again. Okay, so I did overwrite the file, so you can open it now. The file is called crane start. Okay, and maybe to try to don't overwrite it on the network, you can save it directly into your desktop. Okay, so we don't overwrite file. Okay, so maybe you want to sit down, relax. Okay, take notes. Okay, we'll do a couple of steps, then you do. Okay, don't try to follow me, and we go like that. Okay, so you can still open it later. Okay, so the first step before you start rigging anything is always to look at the geometry. How does it work? What it give you? Okay, so always check. So when I do that, usually I will check, is there any naming convention? Is my object freeze? Look at this. If I pick this like that, it's still, is it good? It's not good. You know, I lose all the placement. If let's say I lose my undo, I totally screw up. I shit this object for nothing, right? So what we want to do, we want to pick everything, modify, freeze transform, exit, delete by type, history, right? So even if they have the dumbass come to your scene and try to break it, you cannot do it, okay? So that's the first thing I like to do. And the second thing, I will group things a bit in parts. So what I mean is this. So if we think about this object and this object, somehow they should move together. So what I will do is I will group them together. Then I will call this, for example, tip group. Okay. So this two here and this guy here should obviously rotate together. It's kind of one part, right? So what I will do, I will group together. Okay, I don't know how to call it yet. No, I will just let it like that. So this guy and this pin here will kind of work together. So once again, I can group them together. And this, and this will kind of goes together. Okay, so actually this one, I will call it arm one group. Okay, this one. Okay, so why you name things is to understand things. Okay, if you are lazy, you say, oh, no need to do it. Okay, yeah, sure, be my guest. Okay, you think you're clever enough, fine, you do it. Okay, but at some point you will realize this is a very simple rig. But when you start to have a very crazy rig, you see there's advantage to name things because it doesn't make sense without it. Okay, so name your thing. The swivel and the bottom base, I will keep this like that for now. I will decide later what to do with it. Okay, so that's the first thing I want you to do later. Then if I start to look at this, then I say for joint. Then obviously we need to create joint, and it's for joint. So what I will do is I will go to the side view. Okay, then we go to animation, rigging, skeleton, create joint. Then I will just go here and create a joint in the middle of here. Then we'll come here, create a joint in the middle here. Then go to the tips here. And one last joint. Okay. And actually, to maybe don't confuse you, let's create another one maybe here. Okay. So that is the 4 joint we want to do. Right. So actually, should I do the local rotation axis for this? Yes and no. I mean, if I don't replace them, or I don't intend to animate them individually. Actually, in this case, I don't want to animate individual joint. I want the crane is just one rig, and the rig will use IK all along. So I will never need to change. So because of that, I will not do the local rotation axis. Okay? In a way, I don't need to change it really because it's correct already. I didn't move the joint once they are created. Okay? So that's the 4 joint. And what we want to do actually is this. We want to parent the crane geometry to the joint. Why? Can someone have figured out what this step will do? Tell me. What this step here will do? Parent the crane geometry to the joint. What? It's kind of skinning. But you remember why we want skinning is to have soft deformation. Huh? Actually, is this thing going to have soft deformation? No. So that's why we don't use skinning. Okay? Then, actually, to parent something to a joint, okay, will make the joint. So let's go here. So for example, if I come here and I parent the arm group 1 to the joint here, press P. Then each time I will move this joint, the geometry will move with it. So it's not skinning, but it's just normal parenting. Okay, but is this good? Actually, I will tell you this is not good. Okay. Then, okay, can you just listen? Later you ask question. Huh? Okay, so This is not good because you see when I parent that group to the joint, right? That group here absorb what we call garbage value. And those garbage value, what will happen is they may break your rig at some point. Okay? So actually, remember that. That's the way how I would teach you rigging is this. We never mix the geometry with the rig. We never mix. So then what is my option to make the geometry move with the joint? Constraint, yes. Okay, so what I will do now, one at a time, okay, so I will pick the joint and I will pick the corresponding group. Okay, come here, do a constraint parent. We want to be sure that we maintain offset. Okay, and we want to do a constraint scale. And I will deselect everything, then I can already start to test. Okay, then second thing, I pick the driver, is the joint. I put the new group, constraint parent, constraint scale. Same concept, pick the joint, pick the group, constraint parent, constraint scale. And the last one, pick this joint and pick the last group, constraint parent, constraint scale. So now what do we have? We are able to move the crane from each and every joint, and the geometry is following. Okay, so I will stop here. I think it's enough for now. I will let you catch up on those points, and we continue from there. Just ask us if you have any question. If you want me to repeat, I can repeat as well. Just let me know. Hey guys, now is the time that we start to really put everything we are going together. Okay? Like I say, we are going more to tutorial-based approach now. Now that you know all the tools a bit, you have practiced a bit everything. So it's to put everything together. I'm not sure really of what I'm doing. If you look at my hierarchy here, and I will say one thing very stupid, but apply logic. And I think all of us have different logic, and actually, you guys are still learning about logic. Right? But what makes sense, you know? Obviously, the kids cannot be children of the faith, and that will not make sense, right? So we create group like a robot, actually, right? Or all the body part, similar body part, will be grouped together. So that's it. Okay, and pay attention. Actually, in this case, I said to create 4 joints, but this time I create 5 joints. With the last one here to just be a little bit more visual for you later. Okay, maybe I will just show you the geometry, how I group it. I should not think really that you should look at how I group the things here. What is important is you guys to figure it out. What are my body part? the tip. Look at this. It makes sense, does it? That's the tip. And you move together. Then I have another group called arm tree. That is the arm, right? So because what? Because it's made of 2 green geometry and 1 yellow, right? Then I have another group 2 here, is the yellow pin and the green, right? Then I have the arm, the first arm here, the 2 greens and 1 yellow. And the 2 other one, I didn't do nothing yet. Okay, so do the grouping. Then after that, you create 5 joints. You can do it if you want, but that's not what we do. This would be more like hey, raise your hand, people. Need more time? Okay, thank you. Start on the base. So 1, 2, 1, 2, 3, 4, 5. Okay, so once you have your joint created, you can start to do the constraint. So what does it mean? You want the joint to control the geometry group. Okay, remember to stick to your stance pose. We can test the rotation of things, yeah, sure. But we want to keep our stance pose with the rigging position. You test things, you rotate things, fine. You still need to be able to return to your stance pose. Okay, you may want to save your crane as you go along. Okay, don't want Maya to crash on you for whatever reason. So save your version 1, version 2, version 3. Okay, so please stop what you're doing. I will continue from there and we catch up. Raise your hand, people need more time. Okay, let's go. Instead of constraining 4 times, then you can just constraining 1 time. Okay, let's continue. Okay, so listen carefully and take notes. Okay, so what's the next step here? I say is we create one IK handle, single chain. So what we want to do, yes, we are a bit lazy. We do not want to animate each and every individual joint all the time. Will be tedious. So what I want to do is I want to create IK, so skeleton, create IK handle. And in this case, I want to use a single chain solver, sticky. So I will create it now from the first joint till the this joint here. Okay, so here I will still be able to control this like that. Okay, so that's the first step. So I have my IK. So remember, if you move your IK, remember to undo. Okay, so to return to your stance pose. Okay, and now what I want to do is I will just import the 3 icons I just saved on the desktop just now, and I have 3 icons. So let's see what kind of icon I have. I kind of have a cube here. And this cube actually would be kind of nice to place here. Okay, and what I want to do actually is this, maybe to help myself, right? I will pick the crane group, I will select the hierarchy, and I will put all this hierarchy into a layer so I can hide my geometry. And what I want to do now is this, I want this icon, okay, I will call this guy swivel, so swivel base control, okay, CTRL. And what I want to do is I want this guy to have the same position as the joint. So what I will do, that I will snap, I hold down the V to snap to the joint, right? Maybe put it like that. And what I want to do, remember when we create a controller, right, is to be able to make it easy to select. Okay, so what I will do now is I will just scale the controller to make it easy to select around here. But the pivot is still in the, still here. Then I will create, I will scale up this guy. Then I will call the master control. Master control. Then the third icon, I will snap it again to my joint here. And again, I want to make it easy to select. So I need to see my geometry for that. And I will just scale this guy maybe about that. Okay, so something very, very, very important from now. I should freeze transform my controller. So remember, we talk about stance pose. To keep that stance pose, we rig on stance pose, right? So obviously, right, now if I don't freeze, what will happen? If someone tries to move this, they will always return to the center of the world and they will break everything, right? So we don't want this to happen. So what we do, select all our controller, modify, freeze transform. Okay, so when we have that, so we'll call this the tip control. Okay. So if I refer to this, so we want to create minimum of 2 controller, the IK, so minimum of 2 controller, we need to parent them, we need to place them where I just specify for you. And now the next step is this, okay? Parent in a logical way. Okay, that's why I will start to test if you follow here. So rigging is hierarchy. So now that I will start to have all of this, right? I need to start to develop that logic in my head to create a logical hierarchy for everything to follow. Okay, so that's what I will start to do now. So careful, maybe take notes. Okay, so I think I will start from the tip. I think it's the easier. Because why? Because I can simply pick the IK. You know the IK is here. But the IK is a dangerous element, right? You can break the ring. So now look at this. Okay, sorry, I have a technical issue. Assume perfect angle. Okay, so I will just recreate my IK. So skeleton, create IK handle. Okay, from here to here. So you can see actually that the IK sometimes are a bit temperamental. We don't want to manipulate them directly. So what I will do, I will parent the IK to the controller. So come here, parent it to the controller, press P, and now I will be able to move the controller. And the controller have been free, so it's very easy for me to hit 0 and it return to the stance pose. Okay, so now something very important. Hide the IK. We don't want to touch it, unfortunately, and break things, so hide it. Okay, so I will come here, turn off the visibility. Okay, so that's the first thing. So here as well. So I'm going from the outside kind of in. Okay. So here what happens is I want the crane to rotate on the swivel base. It will just rotate on itself, right? So actually to do that, start to realize that my joint is doing this, right? So actually by parenting the joint to the controller, then if I select the controller, same thing, okay? And if I start to rotate the controller, so, oh, something is missing. So the translation, something occur, but the rotation don't work. Can someone guess what is the problem? Okay, the tip is controlled by something. Then the base is controlled by something. Both work. Right? So now what I want to do is actually parent the tip to the base. Okay, so now look at this. If I parent this guy here, the tip to the swivel base, press P. If I translate this, if I rotate this, right? So this guy can be anywhere where I want. This guy will be able to rotate accordingly. Okay? So, and just to conclude a bit, so this guy, the swivel base, will become children of the master. So now if I move master, everything will follow. Okay, so now let's just fix the geometry now. Okay, so we'll return here. Okay, so where do you think the base, what the base should follow, you think? Now, obviously, the geometry is not following. What should I do? Constraint. So I want the master here to control this object. Constraint, parent, constraint, scale. So now if I do that, what happened? It's follow. Okay, so same concept here. The swivel base. See, when I rotate there, this should follow. So this, the swivel base control, will control this geometry. Constraint, parent, constraint, scale. So what do I have right now is this. I have one hierarchy of geometry, one hierarchy of control that I can translate, scale, and so forth, do more or less whatever I want. Okay, so I can come here and, okay. There is one last thing to do, then it's yours. Okay, if you look at this, the translation, it's working, right? But if I rotate, nothing happened. Okay, so what should I do next? Okay, so you see, this guy here, we have created a constraint to control the geometry. Actually, it's the same thing. Now we want the controller to control the joint control the geometry. Okay, so the controller will control the joint. So it's a orient constraint. Okay, with maintain offset. So now the rig is over. I can rotate. Okay, I can translate. I can pick this guy and rotate him around. move this guy around as well. And that is our first ring. Okay, I think I will repeat that very shortly. But I think you can already carry on with creating the IK system. Bring your controller in. And actually what you should have right down here for minimum and maximum tree controller, rename the controller, place the pivot of the controller and the shape of the controller to fit the rig. Okay? So the pivot of the tree controller will be like that. Huh? Okay, if you look at here, actually, I show the local rotation axis of the sphere here, so you can see where is the pivot of the tree controller. Okay, so that's where you need to place the tree controller, where the pivot is, where the local rotation axis is. It's very important. If you don't place the pivot correctly, the control will not really control the things correctly as well. It can be fixed, but better to do it right the first time. You will come and you will start to say, I want to learn, I want to learn. Okay, so if you are creating your icon right now, maybe you may want to hide the terrain geometry because that would be very difficult to snap. Or maybe better, just use a nerd circle. Nerd circle is a good. Okay, so the naming is there. Okay, be sure your three pivots are there, and I will repeat from there. Okay. Okay, guys, I want you to read that stage. Okay, very simple, where you have your tree icon created and placed correctly. Then also I want you to have a IK, create IK in those, SC solver from here to here. Okay, so we'll wait for you and we continue from there. Maybe, look at this, I give you another 5 minutes, then you go for a break. Okay, I want you back in class at 10:50. Okay, so but I want you to be at the exact same stage as where we are right now. Okay, when we do everything together, take notes, so you can do it together after. Hey guys, all those times of doing icon, like when they see icon, okay, it's just a practice. Okay, just create nerd circle. And if you're taking very long to create icon, don't worry, just create nerd circle. And place it there, use it. Hey guys, the three icon need to be three. Okay, you place them, the pivot is important. If you want them to be three. Okay, so please, guys, be back on time. 10:50, we continue from there. Just be sure you have the same as me right now, all the icon, the IK, we all continue together. Then after that, we will learn how to rig a foot, a leg. Pivot.
children guys also difficulty, and you can spend so much time outside the house.
Okay, guys, let's go back to it. Okay, so we complete this one. Then after that, we will repeat very similar exercise, but this time we will learn how to wriggle legs. Okay, and so forth. Okay, so where are we now? Okay, we are at that stage here that actually we have all the requirement. We have the joint. The joint move the geometry. Okay, what else we have? We have the controller. We have the IK. Everything is there. But now we need to start to think how we can logically parent everything to follow each other accordingly. Okay, so my trick right now, I mean, for this example, will be to start with the tip. Okay, so we already know the IK here. The IK move the tip, right? So what I want to do, I want to parent the IK to the tip controller. So press P. And now let's test the IK, this one. So you see when I move this, you can see that the translation worked fine. But if I try to rotate this icon, the tip don't rotate. So what should I do? Let's investigate to see how the tip rotates. The tip is actually rotating with the joint. So what else can I do? The controller will control the joint in a constraint orient. Be sure you maintain offset. Okay, so now when I do that, I can rotate nicely the tips and I can translate it. Okay, one more thing, and I'll let you do this little part. We can hide the IK. We don't need to see the IK, it's a dangerous element. Even better, look at this, I will do it slightly different. I will turn off the visibility and I right click on it and I will say lock selected. So no one will bring it easily. Okay, so that's a trick. Okay, I'll give you 2 minutes here just to do that. Should be simple enough. And it's actually 2 steps. Okay, very simple. When you start with a tip, try to make sense. If you don't have to do no more. When you use a track, you cannot be all the reading between two lines. So that's why you get now you're way more better kind of like else. Remember the constraint, it said this one constraint, this what happens, this one will move this ability to move. So that is not correct. You have big errors in the controller. Okay, freeze transform, guys. Before we start to do that, ensure that your controller are 0, 0, 1. So the translation rotation equals 0, and the scaling is like default 1. Okay, if we don't freeze up front, you're looking for problem. You will have problem. Okay, so all controller must be free before we continue. You guys remember after constraint, 2 objects are still selected. And it will, if you try to test to rotate, it will not go well. you need to unselect and reselect. Okay, raise your hand, people. Need 2 more minutes.
Okay. No, I can handle to the controller is parent or constraint.
It's parent.
It's parent, right? No.
Okay, guys. Just actually, there's a lot. I will tell you later. You're not listening anyway. Okay, please stop what you're doing and listen to me, okay, here, okay? I will try to repeat a couple of concepts that generally now you seem a bit lost with, okay? So look at me, look at here, okay, take notes or whatever, just stop what you're doing, okay? It's important, so at least we don't need to repeat later to each of you, okay? So actually, if you look at the crane, right, more or less my shoulder is the base of the crane, that's the first part, second part, third part, etc., right? So that's what we want to do, right? Actually, what I want you to realize right now is the overall rig that we're creating, right? Although that we create an IK, right? It's still a forward kinematic rig. Because what? Because if I move the base, this one will follow, this one will follow. If I move this one will follow, right? So to be able to do that, that's why I say it's a forward kinematic hierarchy, meaning that this guy is children of this, and this guy is children of this. Okay? And that's the next step. Okay? And as I say, as the next step, so technically it should be as simple as that. The tip is children of the swivel. The swivel is children of the master. Right? So if I move master, everything follow. Okay? Just ignore the joint for now. Right? So there it is. But I see right now, this guy is silent. Okay? I see a lot of you being confused, okay? And what most of you are doing right now is the same thing I tell you, but you do constraint. So it's mean what? This one, control this. Constraint, parent. Why is this no good? Because now you see if I pick the children, now the constraint, right? This constraint cannot be animated. Right? If I need to animate constraint, you know what will happen. The grandparent will occur, it will decide yes or no, or follow, or whatever. It's not what we want. Okay? In this case, it's a remember, mainly we use constraint to do decision. You're a parent of something and you are not. Kind of thing. Right? So I think the best solution to think is always parenting. Parenting is the core of things. Right? But sometimes you decide, no, this one may have different parent, maybe. So that is where you will use the constraint. But in this case, there's no maybe. This one is a true hierarchy, a true parenting. Okay? So again, so I'll repeat the next step. Very simple. The tip get children of the swivel. The swivel get children of the master. So now if I move the master, we have kind of a hierarchy kind of going on, but something is not really working yet. So what is not working is this guy is lagging behind. So what I will do, I will hop this guy in the hierarchy. So this guy now, the joint, see, it's following the whirl, right? So now we'll say the joint, you will follow the swivel base. So now what do I have? I have something like that where everything's moved together. I can rotate everything. I can even rotate the swivel and everything is following. So what is left behind is the geometry. And like I said at the beginning, I said, I don't know where those geometry will go. And sometimes it will happen to you. Sometimes you can predict, so yeah, okay, my arm, the geometry here will follow this joint. The geometry here will follow this joint. Yeah, sure. But sometimes there's part, I'm not sure. So that's the part I was not sure at that time, right? So now is the time to make follow. So I will go back to my layer here. And again, why do I don't want to parent this guy to this? Can someone tell me? Yeah. So remember when we parent now the geometry to the joint, we are mixing both. So actually, that's what I'm trying to avoid as well. So that's why we use constraint to keep a distant hierarchy between what we consider rig and what we consider geometry. We don't want to mix them. Why? Well, sometimes maybe you do the rigging and your friend are still doing the modeling halfway through, right? So you start the rigging and you know you will need to update the rig. So when you parent all the geometry to the rig, after that it's very difficult to go and find all the pieces and delete them and bring back a new one. By keeping them separate with grouping, it's very easy to reconstrain. Okay? So that's it. So now we'll use the constraint. So the controller will control this swivel base here. So we do a constraint parent, constraint scale. Okay? And the base here will control the base geometry here. Constraint parent, constraint scale. Okay, so I'm kind of done with the rig. Everything should work correctly now. A couple of things we can do on top of it is to hide the joint. I don't need to animate the joints. I can turn off the joint visibility. Okay. Okay. So this guy here, is this guy going to be animate in side to side like that? No. So what can I do? I can pick the translation in X and right click, say lock and hide selected. What else? The rotation in X, yes. Rotation in Z and Y, don't need. So rotation in Z and Y, scaling visibility, no need. Lock and hide. This guy only be animate in rotation in Y. So I will select everything except rotation in Y. Lock and hide selected. So now the animator just have the power to rotate the crane in that axis. Okay, so that's it. We are done with the rig. Okay, so I'll give you a bit of time here to complete that. Save it. And we can continue from there. We will do a foot leg next. Okay, so this is the hierarchy you should have at the end. You can look at it. Compare with yours. If you have this like that, it should work. Okay. By the way, there is other way to make this thing very similarly. There are different ways to do the same method. Okay. say there is a pressure point here when we do rigging is this: we need to freeze transform controller. If you don't do it, you are really looking for trouble. Okay, meaning that you make yourself, you make your life harder than it should be. A controller must be freeze. Who's lost? That's why you place the control, freeze. You lock this down, then you can build. Okay? Guys, the controller, remember this, if you have something to write down is this. When you do rigging, a controller should not have any color. Okay, except keyframe. Okay? If you see blue, if you select the controller and the controller is blue, then obviously you did the inverse. You use a driver as a controller and the controller as a driver. to repeat? Guys, you need to take notes. You need to find a way to make sense out of it, okay? Okay, so how many of you want me to repeat? Okay, so I want to have the total silence and you focusing correctly to understand things. Okay, I'm starting back from the icon. Okay, so again, okay, so what I have so far, right, just to repeat, right, we have the connection, at least the geometry can move with a joint. That's what we have. And I still need to prep my scene. I want to create those controllers and place those controllers before I do anything else. And what is very important and where all of you seems to have trouble right now is this, is where to place them. Okay, so this one here we call the tip control, and let's just call it tip for now. Huh? The tip pivot should be snapped at the same position as this, okay, and call it correctly. This one should be placed here, and this one somewhere around the base is correct. So this guy here will be the master, and one here swivel. But what is very important, guys, this, look at here, okay? It's not enough to just place them. It's important to freeze them. Because what? Because remember, see, look, if I do that, what happened? They all disappear. That means what? That means it will break your rig. So to prevent the rig to break, we need to say this is the default position, right? So that's why I come here to freeze transform, and I will get rid of my little history as well. Okay, so when we have that, okay, so we can start to create the IK. So create IK handle from here to here. So if I translate the IK now, you will see that the IK move the crane. But the IK, if you remember, have something not that great about it, is it is based on world value. So this as well is a dangerous value. So what? To prevent to break the IK, what I do, I will use parenting to another object, and I will use this object. So that's why now I pick this one and we put it children of the controller, the tip. So now what can I do? I can easily translate this. But if you look at the rotation, something is missing. So now I want to associate the rotation of the controller. So remember, the controller should not have any color, and a controller is as well a driver. So this is, the tip is the driver, and the driven in this case is the joint. If you're not sure, actually you need to explore. Say, okay, that's the rotation. So controller, driven object, driver, driven, constraint, and in this case it's just the orientation. Okay, I don't want to translate this joint. Look at this. If I try to translate this joint, it breaks the rig. There's something not correct. That's not what I want to do. I just want to control the rotation. So this one, control this, constraint, orient, with maintain offset. So remember, after a constraint, you still have two objects selected. Don't try to test right now because, oh my God, what happened, Mr. Jack? Mr. Neil, what happened? You still have two objects selected. Okay, so after a constraint, what you do, you deselect, and you can now test the rotation and can test the translation. Okay, so I don't need this IK anymore, so I will turn it off. It's a dangerous element, so I remove it. Okay, so now again, just remember a crane like that is like an arm, and it's an FK relationship. This is the children of everything. This is the middle. This is the parent of everything, right? So I will parent this in this order. So this is the children of this, P. So the swivel became the children of the base, the master, sorry. All right, so now we can see if I move that, The icon seems to move in the correct position, but it seems I forget something at the back. So let's solve that problem. So you see, okay, what did I forget at the back? What is it? Then you will discover, if you investigate a little bit, you will discover that that's the joint here, right? So actually, I will go back to my stance pose, and this joint should become children of the controller. See, right? So now what do I have? My rig is kind of complete because I'll be able to translate the master, whatever the crane want to go. Then the swivel base can spin on itself, and this guy here will control the tip and the rotation, right? So, yeah, so now I just need to fix the last polygon left over. So what happened is the controller will control here, sorry, the master will control the base here, and that's where I want to do a parent in the scale. Why? Okay, let's just do a parent constraint first and see why. Okay, so you can see now, if I scale, right, what happened? Very clearly, you can see all the crane scale, because before, that's what we did a parent and the scale constraint. But now on the base, if I just do a parent constraint, it will not work. Right? So I want to add that flexibility to be able to scale out my crane. So that's why we need to do a scale constraint as well. So constraint scale. Then this part here, if you're not sure, you try again. So where this part should go? Well, am I going to rotate this guy like that? Most likely not. We just rotate this guy in Y. So that's why actually the controller is the best driver for this geometry. Okay, so constraint, parent, constraint, scale. And more or less we are done with the rig. The overall is all done. We just need maybe to do a bit of a cleanup. So what kind of cleanup I'm talking about is this. This object will not be animated except in rotation in Y. I don't need to keep this there. So I will right click and say lock and hide. So same concept. This crane will never be animated in translation in X as well as the Y and the Z. So this and this will never be animated. So I will right click, lock and hide selected. Okay. Even the joint here, I will never animate them. Actually, if you think about it, right, guys, listen carefully, okay? This is something I didn't really mention fully to you yet, but let's start to do that. Okay, in effort to understand rigging, right, I think we need to always keep track of what deform what. Okay, so if we start from the basic, the joint control the geometry. What control the joint? The IK. Then what controls the IK? The controller. Right? So you need to be able to, and what control the controller is the hierarchy of all of them together. So somehow you need to keep track of who deform what. So you will be able to paint that big picture, how to build the logic to parenting. Remember, hierarchy is all about, rigging is all about hierarchy and pivot. So what is this? That's a hierarchy. No, this is this. Where we place the pivot, here, this very important pivot, very important pivot. The rotation of this guy as well, the joint pivot. So that is rigging. Okay. So sometimes at the beginning, it's a bit hard to make sense of all this parenting. But once again, it's by thinking that you will develop that process. Okay. You need to face error to maybe correct it yourself or get information to how to correct it, and it will help you to process. But you need to do it. We need to face error sometimes. Okay, I give you till. Do you still need more time with this? Okay, I give you till 11:30. Well, Okay, 3 more minutes. Okay, anyone else need help to conclude this? Okay. Okay, so listen carefully. What I will do first is this, okay? I will just show you how to make a leg, okay? Up front, I will take 2 minutes, just do it. Then after that, you open the scene and we'll do it step by step, okay? But listen carefully first, okay? So later on, when you will open that scene, okay, you will realize that, well, we have already some joint and this is already skin. So in this example, what we can say the joint control the geometry. That's the first relationship we have, okay? So what we want to do is this. Later on, you can delete those icons. We just want to keep one icon, okay? And this icon is very important to have the pivot at the ankle position. So to do that, we need to hide the geometry to be sure that this foot control ankle, the pivot is at the ankle position, okay? So what we want to do first, okay, and it's written here. So what we want to do first of all, we want to create 3 IK handle, 1 RP solver and 2 SC solver. Okay, so where the RP solver, do you remember what RP is about versus SC? Rotation plane and 3 point, right? So actually the RP solver will always be from here to here. So if I hide this, it's from here to here. So I will come here, skeleton, create IK handle. So I want to have a rotation plane solver, sticky, from here to here. Then I will create another one, and this time it will be a single chain from here to here. And another one from here to here. Okay? So let's name them to understand what we do. So this guy here will be called the ankle. Why? Because this guy is called the left ankle joint, right? So the IK who will terminate at the same place, I will call this the left ankle, the left ankle IK. Okay, so then the second one will terminate here, so it's a ball joint. So this guy here, we will call this the left ball IK. The last one is called the left toe IK. Left toe IK. I really want you later to rename them, okay? To understand what you're doing, okay? So we name them based on the name of the joint, okay? So that's here, the black magic start a little bit, okay? So what I tell you, rigging is hierarchy and pivot. And this is exactly what I will do now in the next step, okay? So now look at this. The ankle IK, I will group it, Control J. So here I have a group, okay? By default, this group will be created in the center of the world, okay? What I want to do now is press the insert key and move this pivot to the ball joint, okay? So now look at this. If I rotate this guy, what happened is this will move like that. Actually, if I take the time here to explain a little bit, see, this guy here, what happened when I move that is very linear-ish, right? But because this guy is children of group 1 now, and group 1 is positioned here, now we can easily do that, that arcs we talk about, right? So if I rotate, it will rotate like that. Okay, so this guy, generally, we will call this the left foot roll. Okay, so now what I do, I will pick the ball and the toe. That is to lock the feet on the floor. So what I do, I will group those 2 IK together, group. It will be named the left toe tap group, okay? And where we place this pivot? At the ball joint again. Yeah. Okay, so now if I rotate this guy here, what I have, I will be able to control the toe only. Okay, so here's a bit of, it's just the skinning. It's not very pretty, but it's the paint weight of the skinning. Okay, so that is the toe control. So what I want to do next, I will group those 2 groups together. Okay, and this time I will move the pivot in front of the shoe. So I will go press insert to move a pivot, and I go in front of the shoe. And this guy will be called the front pivot. Right? So let's call this guy left front pivot or group. It's okay. Right? Another group, so Control G again. And this pivot now, press insert. I will snap it at the back of the shoe. It became the back pivot. So this one, left, back, pivot. Okay? And this guy became children of the foot control. So now what I have, this guy here, it's freeze, right? So I can translate this guy and move it around and always return to my stance pose. And what do we have now? We have a lot of little group to do specific action, right? So that's where we will start to do what I show you, how to do set-driven key to create behaviors. So you remember 0, 8, 10, -10, right? So let's do that. Okay, so I will just show it to you. So what I want to do, maybe I'll just create a simple attribute here. An attribute, it's a flow, and I will call it foot roll. The minimum -10, maximum 10, default 0. So this is a driver. It's it. Set-driven key. All right, so this is my driver. Okay, and the tree-driven, in this case, I have tree-driven object. The foot roll, the the foot roll, the front group, and the back pivot. Okay, so those three here I will load driven, and actually each of them, the rotation in X is what I want to target. So 3 of them, rotation in X. So I will set my first key. So I repeat, when the foot roll is 0, my leg will look flat like that. Sure, that's what I want. Okay, so I already set a key, just set another key. So when the foot roll attribute here will reach 8. So what I want to do here, I want to use the foot roll to roll it to its maximum position. So again, I repeat in my head, when the attribute here will reach 8, right? I want those 3 elements, okay, to look like this. Yes, so I set a key. Then when I go to value of 10, okay, what we want to do, actually, we want the foot roll to return to 0, but we want the front pivot or the front group. Yes. It's okay, it's a demo. Yeah. Okay, so I set a key here. So already we can start to test our set-driven key. So, right, so that's what we have. Then let's go and do the last one, -10. And at that time, I just want to keyframe the back pivot like that. And I want to keyframe everything actually, right? So when it's -10, it's like that. Okay, so that's what the demonstration of everything is. Okay, so now what I want you to do is I want you to open that file here called Iconic Foot Rig Start version 2, and I will do step by step with you. Okay. At least now you see the overall, you see what is expected. Okay. Rigging is hierarchies and pivot. It's exactly what I did just now. Okay, all of you are ready to start? Okay, so I will do 2 steps at a time, and you do. Okay, so first step, I want to delete all those icons except this one here. Okay, and the first step I want to do actually is to place the pivot of this guy at the ankle position. Okay, very important. The foot roll pivot should be at the ankle. Okay, delete all the extra icon and just keep the circle there and move the pivot at the ankle. You may have difficulty to do that. The geometry. Okay, so see clearly where is the ankle position. The geometry. Okay, everyone please stay well. Pivot point in the center. Press and go to Okay, guys, be sure when you do that, right, your controller are still freeze with 001. Okay, so
Everyone got this stage? Yes.
okay, listen carefully next. So what we do next, we go to skeleton, create IK handle. And the first IK I want to create is for the leg. So for the leg, we use a rotation plane. From this one here is called the hip joint to the ankle joint. So that's why I will call this IK left ankle IK. We'll do the 3 IK and you do, okay, listen. And so the first IK is a rotation plane. You should see the line in front like that, okay? So I return to the IK mode. I click here on the ankle to the ball joint. So this IK will be called the left ball IK. And the last one, from the ball IK to the toe joint, sorry. And this one here will be called the left toe IK. Okay? So, yeah, that's it. Okay, so I will let you some time here to catch up on that.
I still like it, all like it, so like it. Yeah. Single click. From hip to ankle, RP, the next thing is single click. Yes. That's okay.
If you create, yes, if you create your IK in the wrong method, let's say you create your IK as RP and you want it to be SC, just select it, Control A, and you open that in the attribute editor called IK Solver attribute, and you can change here for what you desire. Okay, if you have been created before. Okay, else you just delete and redo. Okay, guys, you need to understand once. Okay, listen here. Okay, whatever what you're doing, okay, just stop. Okay, once the IK is created, okay, I don't want to see you translating a joint. You can see it will get all crazy. Okay, it's not meant for that. Now, what you should understand by now is this: is when the IK is created, it controls the joint already. So now, if I try to do that exercise I was doing with you just now, now it's that the IK control the joint control the spinning, the geometry. Right, so that's the hierarchy we have so far. Right, they are not.
Class, have you created the 3 IK handles?
Okay, so what is next? Okay, actually very simple. I will slightly do it different for you right now. I want you to do 4 groups. One group, Control J, deselect, Control J, deselect, Control J, deselect, Control J, deselect. Okay, so the first one, we will call it the left foot roll. The second one, we will call it the left toe tap. The third one, we call it the left front pivot. And the last one, the left back pivot. Simple enough.
Can you do that? 4 empty groups and name them. Four empty groups. Control G.
Okay, so what I want to do next, you get the naming right? Can I continue? Okay, so what we want to do now, we want to build our hierarchy and place the pivot accordingly. So what we want to do, we want to pick the foot roll and the toe tap, and we put them children of the front pivot, P. Then front pivot, children of back pivot. Then back pivot, children of foot control. Be sure foot control is freeze. Okay, so I will stop here. Oh, sorry. Front to this, this to this. Okay, so it should look like this now. Yeah.
Okay, class, do this please. Foot roll and toe tap. Children of front pivot. Front pivot, child of back pivot, back pivot, child of foot control. Everybody happy after that.
Okay, simple enough. Okay, so now what we want to do, we will place the pivot correctly and finalizing the parenting. Okay, so actually let's finalize the parenting first. So the left ankle will be children of the foot roll. And the two other IK who lock the feet will be children of the toe tap group.
Okay, can you do that? Ankle IK, child of foot roll. And the remaining 2 IK, child of toe tap. Ankle, child of foot roll, yes. Ankle, child of foot roll. The remaining 2 child of toe tap.
Okay, so like I was telling you guys, somehow rigging is hierarchy. And now we have that hierarchy. But we need one more thing. Okay, now is to have correct pivot. Okay, so the toe tap, okay, actually you can do that in double. So the toe tap and the foot roll, those two. I can select them both, press insert, and I will snap it, hold down the V key, middle mouse button to snap it to the ball joint. Just wait. Okay, so why I do that is because now with the rotation from there, we will be able to, the foot roll, raise the heel, and the toe tap will tap the toe, right? Then again, just give me 2 more seconds, right? Okay, so the front pivot obviously will be at the front of the feet, right? I mean, it should be simple. So press insert, hold down middle mouse button and V, you can snap it to the vertex in front of the shoe. So same thing, the back pivot, hold down V, middle mouse button to drag the pivot at the back of the shoe. So now you can test them by rotating them. So each pivot, each group that we call pivot or toe tap will have a specific function later on, right? But that's the power of pivot and hierarchy.
Foot roll and toe tap is snap to the ball. Front is snap to the front of the foot. Back is snap to the back of the ball.
If you snap my ball, I will not be happy. So I don't know if you read that. Snap to the ball, snap to the ball. Okay. I show you how to move the pivot point in case you don't know, you forget. Okay, listen carefully. I will show you with the sphere. Okay, so when we have an object, the pivot is in the middle. How to move the pivot? You press insert. You can see the difference with the icon, right? So when it's this icon, you can move the manipulator where you want. And when you're done, you press insert again. So now the pivot is at that position. So that's how we move pivot. Press insert and be able to move the pivot. Here, raise your hand, people. One more time. No one? Good. Okay, listen, guys. Okay, so the last thing for today, and we are done. Huh? And, oh, okay. So the last step is to create the behavior. It will not be nice for the animator to pick this guy and maybe rotate it and come back in the hierarchy and come here, pack the pivot and rotate it. It will not be nice for him. Okay, so that's why we create a behavior. Okay, so what we want to do next, we will select our controller. We will add attribute like foot roll. Foot roll. -10 as a minimum, 10 as a maximum. And this, obviously, this attribute is a driver. Okay, so I will let you the time to do it and load it. So you select it, exit, set driven key, and we load the driver. Select the foot roll attribute. And the tree driven attribute will be the back pivot, front pivot, and foot roll. Load driven. Actually, let's start to do a simpler one first, okay? So actually, we can have created the foot roll attribute. Let's create another one easy. This one will be the toe tap. So -10, 10, 0. Okay, let's just do those two, and that will be good enough. Okay, so the toe tap will control the toe tap group here. So load driven, and I need to know what is the rotation. Is the rotation in X? So very simple. Select the rotation in X, and I'm ready to set my set driven key. When toe tap is 0, my legs look like that. So yes, I set a key. When toe tap goes to 10, then my driven object will go up. So set a key. Repeat in my head, when it goes to 10, my legs go up, so I set a key. When it goes to -10, do the opposite. So come here, rotate, set key. So what do we have? We have the control over our toe. That one is simple, right? So I give you a bit of time here, and I do the last one. this section. Okay, so just as an overview, remember your test after the third grade will be to bring a two-leg character. Okay, so yes, what I'm showing you now about that leg is very important for you to memorize it. Okay, it's just an introduction today. We will practice this many times again. Okay, but today is a very simple introduction. So you need to master that. Oh, shit. Okay, so let's do the last adjournment key, then we are done. Sorry. Okay, so the last one is the foot roll. And the driven will be a combination of the foot roll, front pivot, and back pivot. And we load driven. And you need to keyframe 3 of them at a time. Huh? When you set a keyframe, be sure that 3 of them here are selected. Okay? So again, I repeat in my head before I do a key pose. So when foot roll is 0, my 3 attribute, rotation and X, will make my leg look like default. It's correct. So I set my first key. Then I go to value of 8. Then I will activate only what we call here the foot roll. Okay, so I will go to a maximum. Obviously, this is kind of too much. It popped the leg, right? So I will go about that. And I repeat in my head, when the value of foot roll is 8, my legs will look like that. Most likely my feet. Look like that. Yes, it's what I want. Remember to select 3 of them and set your key. So already we can start to test between 0 to 8, right? And now let's push it to 10. So actually what happened when we go from 8 to 10 is this. The foot roll get canceled. and the front pivot will rotate now to its maximum. Okay, and I repeat in my head, when foot roll goes to 10, those three attributes, rotation and X, make my feet look like that. Yes, I set a key. So already now I get my behavior between 10 to 8 and 8 to 0. And let's do the opposite way now in -10. When you go to -10, we want to rotate only the back pivot to its maximum. Okay? And again, I repeat in my head before I set my key, when it's reached -10, those three attributes, rotation and X, will look like that for the feet. Set my key, and we are done for today. I think Mr. Anil want to give you your grades and comment. So let's review that, but that's how we do set-driven key. Like I say, we need to know that because you will have a test about that. Okay, so it's very important. If you don't understand, try to seek advice today or maybe during your term break. But also, we will repeat that after term break. But if you don't know, if you're very lost right now, you may want to catch up during the term break. Okay, guys, maybe just to clarify things, okay? Okay, so the set-driven key is to set a behavior, okay? As 0, 8, 10, -10. Okay, but it's not an accumulation of the rotation of all those groups. So what I want you to understand is this is, we don't come here and rotate 3 of them at the same time. For sure, you expect rubbish. You know, it's like you select all of it and you turn them in the same direction. It will all go crazy. It's a specific set of instruction. Okay? Why do I select 3 of them here? Is to set a key. Okay? But after that, I come here, I just select 1 and I do what I want to do with 1. But I come here and select 3 of them because I want to keyframe 3 of them. Okay? So it's different.
Can you make the announcement? Then we can send you.
Yeah.
Okay, Danny.